Well, I think it's time to start. Well, good afternoon. Hello again. I'm going to talk about TDD. It's not going to be a technical talk, but more talk about what I have seen in the last 2-3 years teaching TDD, not only at the university but also in the industry. Yes. So I'd like to start asking how many of you are working with TDD or no? Okay. And how many of you really do TDD? Okay, 2, 3. Okay, cool. So, what is TDD? We usually see the 3-4 steps that are part of TDD, yeah. But I want to start saying that this is not real. This is not really what TDD is, but how you do TDD. The essence of TDD is something different. Yeah, those are the steps that you have to follow when doing TDD. But the essence is a little bit different. There are a couple of things that are misleading about TDD, and one of them is, for example, the name. Yeah, the name. When you talk about TDD, people think about testing, and testing is the less important part of TDD. It is important, but not the most important part. So the first thing I'd like to say is that TDD is not about testing only. Yes? TDD is about doing incremental, and I wrote problem solving instead of development, guided by concrete examples. The idea of TDD is that you develop your system, your model, starting with concrete examples that are the test, and you do it in an incremental fashion. And of course you say, yeah, I do incremental development at work, you know, we use Scrum, we use, I know, XP, and we have iterations, and blah, blah, blah. Yeah, but that's not what I'm talking about when I say incremental problem solving or incremental development. We're used to do incremental development or cycles of iteration at the project level. Scrum is that. But as developers, we are not used to work in an incremental way. For example, when we face a problem, we usually try to solve the problem at hand, you know, to solve all the cases that the problem represents. And that's not incremental. An incremental way of doing development is about solving each case per case, and then getting to the final solution after solving each of the cases of the problems that have to be solved. It's difficult in English. Another important thing about TDD is that brings testing to the development cycle. We usually see testing as that final step in our development cycle. Testing is done by those guys that nobody likes, that they're always trying to find my errors, and they're very happy when they find an error because they come and they, pick on me and, hey, man, I found you an error. Yeah, so we hate them because they find us errors. Yes, but the idea of TDD is that get TDD inside the development cycle and get testing inside the development cycle and do analysis, design, programming, and testing all at the same time. And having testing at the same level as design, as analysis, and programming, yes? And, be serious about that. The good thing about TDD is that make tests explicit. Yeah? We are always testing. When we develop software, we are always testing, but we do it in our head. In our head, we are thinking about all the situations that our program has to solve. Yeah? We do it implicitly. The good thing about TDD is that forces us to do it explicitly. Of course, automatically. And of course, another good thing is that it brings requirements to life. Because after doing TDD, all your tests are like requirements that are alive. Yes? And if you make a change or if you add a new test, you can see it as a new requirement that helps you to understand the system and what the user wants. The interesting thing about TDD, from the programmer point of view, this is very important, I think, is that, I don't know how to say in English, sinceriza, but it's about making, the programmers have to realize that testing is part of programming, and that a good programmer has to be a good tester. There is no way for a programmer to be good without being a good tester. Programmers that don't take care about all the problems that have to be solved, programmers that do not test what they do, are not good programmers. They can, be great on design, they can think about all the problems, not all the problems, but if they don't do good testing, they are not good programmers. And that's very important, and that's what I'm saying when I say that TDD sinceriza that situation of the programmer. So now the programmers cannot say, hey, don't ask me to test, I'm just a programmer. No, a good programmer is a good tester. And of course, TDD, we have to understand this, is a big cultural change for us and for all the company. And that implies very important stuff when you're trying to do TDD in a company, in a group. Those are the things I'm going to talk about. So, okay, after that short introduction, we're going to see the commandments. I wanted to do a joke, like analogy. I hope nobody get mad with me with this. But we're going to see like different things that you have to follow, and from the management point of view and the technical point of view, and in the technical point of view, from the design and testing, okay? And sadly, there are more than 10, okay? The 10 commandments is just a joke for you to come here. They're like, I don't know, 100, no, not that much. So, the management, here we have the best manager in the world, Dieguito. Well, the first thing I would like to say is that you shall not expect your developers to do TDD because they are God. Because they are good. Yeah? As a manager, you cannot expect your developers to start doing TDD because it's nice. Maybe they will. Maybe they will go to a conference and see, hey, look at this technique. I like it. I want to do it. But because TDD is a cultural change, it's not enough for one person or two persons to push it. It has to have support from the management group. Cultural changes do not happen by themselves. It's very important to support those changes. So as a manager, you have to provide the right environment for this change to happen. It's very important. And of course, sometimes, if you do the other way, if you are the manager that want your people to do TDD, sometimes you have to be tough with your people. It's not enough to say, hey, as a manager, we will start doing TDD, just why don't you start doing TDD? Yes? Depending on the team that you're working with, some people will say, yeah, let's do it, and we'll take the stake and go and try to do it. And some people will say, why? Why do I have to change the way I work? And they will start, stopping the change. And that's, when a good leader, when a good manager start, taking the problem by himself and solving that. Another important thing when starting to do TDD is to do it with pair programming. Yes, pair programming has a very nice, interesting characteristics, and one of them is, helping the other guy not to tirar la chancleta. Yeah. Sorry, I don't know how to say that in English, but when you are programming. And you get to a problem and you say, how can I test this? And if you're alone, don't worry, I won't test it. Nobody will care, nobody knows. Yeah? So it will pass, nobody will see it. But if you're doing pair programming, the other guy will tell you, no, come on, let's try to think a little bit. Let's think how we can test this. And that's the good thing about pair programming when you're starting to do TDD. as a developer, as a manager, you should provide time to do TDD. You know, it's funny sometimes when I go and teach TDD and the manager asks me, oh, but do the programmers need more time to do TDD? Of course, man. I mean, they're doing more stuff. Of course they will need more time to do TDD. And then they say, oh, no, we don't have time to test. Well, okay, so that's how your product is going to be, yes? I mean, TDD at the beginning and in the short term takes time. Takes time to learn it, takes time to do it. But the important thing is that it is an investment in the middle and long term. I mean, finding a bug, running the test during a regression has no price. No? We know for the rest we have MasterCard. Yeah? But finding a bug before putting in production the code has no price. So it is really an investment. And that's the way a manager should think. Also, this is very important, the manager should not send mixed messages. You know, for example, stop doing TDD because we don't have time. It's very common. And this is funny because sometimes the managers, you know, they have these big plans, no? When they say, yeah, we have to, you know, finish this task in next month, the other month we are going to go to production, and they forgot that a plan is a plan. It's not the reality. It's not what really happened. It's not what is really happening. It's very important for the managers to understand that the plan can change, and it's important to change it if it is necessary to keep what your main messages to your team are. For example, if you decided to do TDD, if you decided to go and do quality software, then you have to stay with that. And if you cannot do it, just provide a good explanation. And not say just stop doing TDD. Explain why. Talk to your people. It's very important. Oh, this is a good one. You shall not expect no errors at all when doing TDD. Yeah, I have a story about a manager that he loved TDD, and so at the next day he saw how the technique worked, went to the company and, you know, forced all the developers to start doing TDD. Yeah, let's start doing TDD. Blah, blah, blah. He pushes very hard. Blah blah. So after 2 months of working 16 hours per day, etc., they could finish what they had to finish. And what happened? At the second day of the product being in production, there was an error. And he said, oh no, how could it be an error if we were doing TDD? How is it possible? And what happened? He said, well, let's stop doing TDD. TDD doesn't work. Yeah, the usual way of thinking of some managers. And that happens because they don't understand what testing is all about. You know, Dijkstra just told us what testing is all about a long time ago. And testing is not a formal verification technique. So you cannot say anything about something that you don't test. You cannot say if it works or if it doesn't. So do not stop doing TDD because you got an error. What you have to do is to start thinking how to do it better. Yes, and there are tools for that. One of them is Coverage, that is not a good one really, and of course mutation testing, and there is a very good tool about mutation testing for Smalltalk. The best one. This is another interesting thing that maybe the people from the foreigners won't understand it, but that's 100% lucha. Okay? So, you shall not expect to have 100% coverage, okay? It's impossible, almost impossible, and sometimes it doesn't pay. And I remember in a company here in Argentina when we were teaching TDD to the guys, and a company that sells products on the internet, they were very excited about doing TDD, and when I went to the company after a while, the manager told me, well, now I will meet with the guys that are doing TDD, so what should I ask them? How would I know if they are doing TDD really? And I said, well, So we started to talk, and then he said, okay, I will ask them 100% coverage. If they don't do that, so I will punish them. No, man, you're crazy. It's impossible for them to have a 100% coverage of code when they just started to do TDD. They're just learning TDD, and you're asking them 100% coverage. Even if you have enough experience with TDD, it's almost impossible to pass 80%, 70% of coverage. And sometimes it doesn't make sense to do it. So it is important to understand that TDD doesn't cover everything. It's not the solution for all the problems you may have on quality, on software quality. This is another one. You shall not remove the QA team because you are doing TDD. It happened also. I have a company, I know a company, that they started to do TDD, and the guy, the manager said, okay, so now we're doing TDD, we don't need QA anymore. So the guys at QA, they have to start programming or they have to leave. And they did it. Yeah, they did it. They lost a lot of people from the QA team. Some of them went to do programming, and after 2 months, they realized it was a bad decision. And they had to bring people to QA again. Yeah, so Leandro yesterday said that they realized that TDD was not enough to find all the bugs. And yeah, that's true. There are a lot of other types of testing that you have to do to your system that you cannot cover with TDD only. For example, when you're testing the UI, user experience, performance, scalability. And the good thing about TDD, because if you think like a manager, you say, okay, I'm doing one more stuff. I'm doing TDD. What do I gain? Why should I do it? And the answer for that is that when you start doing TDD, your code is better. So QA gets less errors, and they can concentrate on the real important ones. And the cycle between development and testing gets shorter, and you have less cycles. So it's not that when doing TDD you're not going to have any errors. You will have errors. The errors are there. They will be always there. But you will have less one, and QA will be able to concentrate on the important ones. And that's where you see the money going back. And of course, because it is a cultural change, as a manager, you should want your team to be test infected. This means you have to let TDD grow inside your team. It takes time. It's a cultural change. So you have to wait for your team to become expert. It doesn't happen in 1 week. It doesn't happen in 1 month. It takes time. 3 months, 4 months, depending on how you do it. It's not something that you say, hey, let's start doing TDD, and then the next day, you know it. And again, it's a good, pair programming is a good solution to start when you start doing TDD. And also, if you're doing pair programming, it's a good idea not to mix, for example, a junior programmer with a senior programmer. Because the junior programmer will not understand anything about what the senior is doing, and the senior will, hate the junior programmer after 5 minutes because he doesn't understand anything. Yes? So how you have to make those pairs? Just put a semi-senior with a junior or a semi-senior with a senior. Because that's how they will understand each other better. And this is a technique not only for programming, it's a technique for other type of my English today is not good. For all types of professions that they have to work together. For example, airplane, the pilots. No, James can talk about that. Once I have a story also. One of my brothers is a pilot, and I remember when I saw a news on the newspaper saying that they were going to remove the co-pilot because it was too expensive for the companies to keep it. And I asked him, hey, is this real? can they remove the co-pilot? Because what happens if the pilot gets sick? And he told me that it's impossible. It's impossible to remove the co-pilot, but not because the pilot can get sick, but because if you remove the co-pilot never learns. And the co-pilot needs time to learn how to fly a plane. So the same thing happens with us when we are developing. We need time for the juniors to learn how to program. And pair programming is a good way to, to teach those guys. So okay, that's enough about the management commandments. We'll start with the technical commandments. Well, the first one is the most important one. You shall write the test first. If you don't write the test first, you are not doing TDD. You may be doing testing, but not TDD. Yes? I mean, if you write the code and then you write the test, you are testing, and that's fine. But that's not TDD. And why it is important to write the test first? Because, first of all, it's an incremental design and programming technique. If you write the code that solves all the problems, then you are not doing incremental development. So it's not about providing a generic implementation at once. And the idea of writing a test before the solution is that you also have to keep your anxiousness about solving the whole problem. The idea is to, and I think it's this one, no. The idea is to test one case per test and solve that case alone. And make your solution grow from cases, from tests, one by one. It's very difficult to explain that in English. Well, of course, you shall assert in your test. I have seen tests that have no assert at all. And I ask them, oh, how do you know it works? Well, if it doesn't fail, it works. No, come on, man. I mean, if what you're waiting for is that no exception gets thrown or gets signaled, so you have to assert that. Say explicitly, no exception has to be signaled. So it is important to understand that you have to have an assertion or more. This is a very common mistake also. You shall not write many tests and then try to run them. Sometimes when you start doing TDD, a lot of programmers say, okay, oh, I have a new idea, I will write a test. And then they have a new idea for testing, they write a test. And they write like 10 tests, and then they try to make them work. And what's the problem? The problem is that when they make work the first test, they realize that the design that they thought is wrong. And that makes them change the other 9 tests. Yes? So the idea is to write one test, make it work, and if you have another idea in mind when you're writing the first test, go and write it in Notepad, wherever you want, but don't write the test until you first make it run the other one. Yes? So one by one. Well, this is another of the problem of the names of TDD, and it's related to the name of the framework we use to test. The framework in Smalltalk is unit, in Java JUnit, PHP unit, COBOL unit. I don't know why is that, I mean for what, but there's one too. And so the problem is that because we use a tool called SUnit, we think that TDD is about unit testing. And it's not true. It's not only about unit testing. First of all, unit testing is very difficult to define. Some people think that unit testing is about testing a method or testing a class, and that's all. But the most important tests are about the functional test, not the unit test. And people is starting to realize that, and they're starting to change what the meaning of unit testing means, what the meaning of unit testing is. So now, for example, unit testing in the Agile community is starting to see as tests that run fast. Like, for example, in 10 milliseconds or 50 milliseconds. It doesn't matter how much covers. It has to run fast, and that's a unit test. And again, the most important tests are the tests that you use to cover a whole functionality and not to test one method. That doesn't give you too much value. One common problem is when you start doing TDD is how do you call your test? How do you name them? And here there is another problem that most of the examples that we see in the books, the name of the test are really bad names. For example, test add or test subtract. What does it do? What is it testing? Which case? Adding with 0, not adding with 0, adding negative numbers, adding positive numbers, different cases. So test add doesn't tell me anything. The name of the test should be, of course, named after not after the how, but after the what. And the name of the test have to be functional names. For example, test given an account without transactions when asked for its balance, then it should return 0. That long? Yeah, that long and longer if you need it. I mean, test names have to be based on the functionality and the case that you are using to test. You cannot name a test like test balance as 0. That's not a good name of that test. That name tells you, this is the situation where I am, there is no transaction in the account, and then I should get 0 as the balance. Yes? Very functional. Well, this is very difficult to explain, but you have to verify one case per test. And here the word case is very similar to test, so it's very difficult to understand. But the idea is that if you are testing the adding, then you have to test when you add 0 in one test, when you add another number that is not 0 in another test, than when you add a negative number in another test. Those are different cases. If you are testing the balance of an account, you will have to test it when the account has no transactions, when the accounts only have deposits, when the account only have withdrawals, when the account has deposit and withdrawals. Different cases, different tests. And why do you have to test a case per test? Because you are doing incremental development. If you test all the situations in one test, then you are not doing incremental development anymore. You are trying to solve the whole problem at once. And the very important thing is that if you have a test that tests many cases, when the test fails, then you won't understand from the name of the test what the problem is, and then you will have to go, read the test, understand it to see what the problem is. In the other way, if you have one case per test, if a test fails, by the name, you will know exactly what the problem is, and you won't have to see the test and read it. So if you have problems to put the name of a test, maybe it's because you are trying to test more than one case. When you have too many cases to test, it's very difficult to put a name, and then we start calling them test add. Of course, we shall not test twice the same thing. This is very common but very difficult to maintain, and more when there are a lot of people working on the same problem. Your tests are another system, so you shall keep your tests as clean as the system that you are writing. Yes? Tests are like another system that are using your system. So they have to have a good design, they have to be clear, they have to be understandable. And that's very important when your system is big and your tests start being a lot. And that happens very fast. There are some techniques about you know that about TDD, they start, for example, from the interfaces of a system. And they start mocking all the model that you have to develop. My advice is that you never start testing from the interfaces, but you shall start testing the business model first. Interfaces can change. Interfaces can be many different interfaces, like a web service, a JSON interface, whatever, a user interface. But the model that you are developing is not going to change because the interface changes. So you shall start testing your model and not the interface of your system. Another problem of start testing the interfaces of your system is that make the time to have the test running longer, because you have to write more stuff to make the test run. Because if you are testing your interface, you have to write the code of the interface, you have to write the code of the model that that interface is using, and blah, 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 blah. You have to make a long trip to make that test work. If you are writing the test only for the model, then it's less code that you have to write, and then you will have the test running faster, and that will give you, that will make you feel happy. It's very nice to see that all the tests run, you know. This is another problem. I'm so happy with Smalltalk and Gemstone that we don't have to use relational databases. But you shall not use relational databases when doing TDD. That's a big mistake. Why? First of all, because databases are slow. Databases are slow. So when you're doing TDD and you have to use a relational database, that test that could run in 10 milliseconds will run in 2 seconds. And then 100 tests will run in 200 seconds, and so on and so on. It will be very slow to run all the tests. The other problem is that relational databases make your development harder because you have a paradigm problem. That's a design issue. In one tool, you have to think about, rows and columns, and in the other, in your system, you have to think about objects. And of course, that can misguide your design. So the advice here is not to use relational databases when you are doing TDD. How you do it? Well, depends on the language that you're using, depends on the frameworks that you're using. But for example, it's very common to see guys that are developing applications with Java, for example, to start putting annotations on their code, annotations for hibernate, that tells how the objects are mapping to the databases. Well, that's something that you should not do if you're doing TDD, because that is coupling your database with your model. If you're, using Hibernate, make all your mappings in a different object. Configure the mappings in a different class. Do not use annotations. That will not allow you to run your test without the database. This is a more general rule based on the previous one, and you shall not test using external system. A database is an external system, and should not use external system when testing. Why? Because, again, it makes your test slow. An external system like an HTTP server, a mail server, or whatever, will make your test slower, run slower. An external system avoids your test to be in control of everything. External systems have to be simulated, and that's the next commandment. I didn't know what picture to put here, so I thought, well, my wife is always controlling me, so, bad joke. So tests have to be on control of everything, and when I say everything, I say everything. A test must control the environment it must control what is happening in the environment, it must control the external system. You cannot rely, for example, in an external system on the data of an external system for your test to run. Somebody will go and change that data in that external system and suddenly your test will not run. Another example is when I go to the companies and we start talking about TDD, they say, oh yeah, but we have one database for all the developers. Well, that's not going to work. That's not going to work. You cannot share one database with all the developers and try to run your test. Because if somebody changes the data, so suddenly the other guys are going to have an error in their test. And they won't know, they won't know what's going on. And it's the worst thing that can happen to your test is to become fragile or unreliable. Fragile tests are tests that sometimes they run, sometimes they doesn't. Sometimes they run, sometimes they doesn't. And when that happens, you start losing confidence in your test, and then you don't run them anymore. So if you have those kind of tests, just remove them. They don't make any sense, or try to solve the real problem. So if you have to test using databases, give one database to each programmer. Don't share the database. And it's interesting to see that when we say that you have to be in control of everything, for example, time is one of the things that the tests have to be in control of. How the time passes. The tests have to, in some way, control how, what time is it, what day is it, to be able to verify that the code is working correctly. That's a very interesting exercise to solve, to a problem to solve. And of course, when the tests have to be in control of everything, you need to start, simulating objects, using mock objects, using fake objects, whatever. You need to do it. But please, you shall not mock your wife. Yes? I mean, don't try to mock everything. Mock objects are like the tool that you learn as a new tool and you try to use it to solve any problem. So that's mock objects, okay? You should not use mock objects inside your model. You should only use mock objects to simulate external system, things that are outside your model, not inside your model. Because when you start mocking your internal objects, your model, you are not testing your model. So sometimes people say, well, but it's very difficult to create all these objects. It's very difficult, so I will mock them. No, man. Do not mock them. Just create an object that will return the object that you want. And you will start creating objects that create objects. And then you will be able to create objects easily. That's the solution. Not to mock the objects, but to create factories of objects. And then you will be really happy. You'll see. And this is a very important one. You should understand that TDD does not imply good design. Sometimes TDD guys say that doing TDD, you get a good design, and that's not true. I can do TDD, and I can have copy-paste all the program, all the code. It's very simple to do it. TDD does not imply good design. TDD implies a less coupled design, that's true, but not good design. Good designs are done by good designers. And, if you want to do a good design, you have to learn how to design. TDD will help you a little bit to have your design less coupled, like I said, but it doesn't mean that you won't have repeated code. It doesn't mean that the responsibility of your objects are going to be well distributed. It doesn't mean that your objects are going to be, cohesive, etc. And of course, another thing that usually happens when you start trying to explain how to do TDD and this incremental way of developing is that I usually get sentences like, so when doing TDD, you don't have to think. What do you mean you don't have to think? Yeah, because you have to put all what you need. No. If you stop thinking, then you stop programming. You cannot stop thinking. Doing one step, at a time, it doesn't mean that you don't have to think. Okay? I mean, our work is about thinking. So TDD is not about not thinking. It's about understanding how to do an incremental development based on concrete examples. And that's it's very difficult to explain this without an example. I don't have time to show an example, but that's the most important thing about TDD. Well, of course, you shall not worry about performance at the beginning. And at the end, as a programmer, you shall love testing as much as programming. Okay? A good programmer is a good tester. There's no other way. We have to face it. We're always testing, and now with TDD, what we have to do is to make it explicit. Testing is part of our job. So, I will finish with a joke. Not kill QA. You shall not commit adultery forgetting to write the test first. You shall steal other test ideas. You shall not bear false witness against TDD if you have not tried. You shall covet your neighbor's test. You shall not covet your neighbor's lack of testing. So, questions? Any question? Yeah.
¿Podrías contar rápidamente qué consiste el framework de mutation testing?
Mutation testing, yes, it's very simple. The technique is about changing your code, make small changes in your code. For example, to change less than with a bigger than, and then run your test. If all your tests run, it means that that case is not covered by your test. If one of the tests fails, it means that that case is covered by your tests. So that's the idea. You have mutators that change your code, and then you have to run the test based on those mutations. It's a forza bruta technique. Brute force technique. Another question? Questions? No questions? What? Oh, yeah. I don't see.
It keeps bugging me that those things of the long names on the test. So, convince me. What if I, on each assertion, I make a signal in the phase with an appropriate message explaining why is this failing instead of the long names?
Yeah, that could work, but remember that when you see the result of which test phase, you see the name of the test. I mean,
you can see
at the same time, you can see the description of the assertion that failed, but the description for sure will not say what case you were testing, but only what failed. I mean, what's the problem with having long names in the test?
maybe I know.
Okay. I hope you get used to long names. That's fine too. I mean, I'm not saying not to do that, but I mean, it doesn't avoid. It doesn't. I mean, if you do that, it doesn't mean that you don't have to have good name for the test. Yeah.
I have a question.
Oh, time's over.
No, I extended you 5 minutes. I'll go 30. Anyhow, what happens? You made a comment before about the tests that have no assertions, and for instance, oh, well, you know, just write this test and it doesn't fail, and so it's okay because if it failed, then you get a failure, etc. But you should assert that no failure happens.
Because other people that can see that will see that test won't know if you forgot to assert that or you wanted to do that.
At the same time, I wanted to ask you what do you think about this, because I found that if you use shouldn't raise, for instance, you could say 3 divided by 0 shouldn't raise message not understand. But if you have something else, then the test passes and it's still broken. So for instance, I don't know, you try to connect to some socket and you say, well, shouldn't raise can connect. Yes, but the message not understood because the code is broken and the test passes anyway. Do you have any thoughts about that?
Yeah, well, that if you, the problem is that you wrote the assertion wrong. I mean, if the problem is that you're asserting that no exception should be thrown, well, the problem is that message not understood should not be in the hierarchy of the, of error. That's the first problem. Message not understood is an error that is not part of your model, but is part of the meta model. So it should not be the same hierarchy, and that's the only case when you have this problem. Yes? So to solve that concrete example that you gave me, my suggestion is we should change and remove message not understood from the hierarchy of exception and put it in another way, in another part of the hierarchy. Because it's also very, it bothers a lot when you are doing incremental development and you have a kind of assertion like that you cannot do it because message not understood is the error that you're using for the debugger to pop up and continue working on it. So the problem is that message not understood is a meta level exception, it's an exception of the meta level of your system and not of the model of your system. Yeah? Did I convince you? We can keep talking. Yes, last one.
It's a nice
At the university, I had many students that were invited to TDD when asking how was their experience. Some students answered it was a very good experience. Others answered that it was a mess to refactor when they did make a very high refactor because the design is in nature when they wrote the tests. The students that answered that test TDD was excellent didn't pass the immature step. They had the design clear at the first time. What do you think about that?
Okay, yeah, it's true that when you're doing TDD, if you know exactly what your design is going to be, it's going to be easier because of that problem. But at the same time, when they ask me that, I say, okay, and what would happen if you wouldn't have the test and you had to do that refactoring? Well, I mean, would you be sure that that refactoring was okay? How do you verify that? So the problem is the same, no matter if you have test or not. I mean, being sure that the change that you made is correct is what it is important. And of course, if you have the test that are a system using your system, if you change your system, the one that depends on yours is going to change. I mean, but I prefer to invest and waste time making the test work and not having the error on production because I didn't test that change and I'm not sure about it. So yeah, of course, it will take you more time to make a design change when you have tests, but at the same time you will be more sure about it.
then it is necessary to traverse this inconvenience, the writing of the tests when the design is in major.
Excuse me, what? La decisión del plan.
La impresión
No, porque estamos...
la impresión de los alumnos era una impresión superficial.
No, it's not superficial. It is true. It happens. Of course, it will cost you more. If you are making a big, not a refactoring, because a refactoring is a change that you can do with a tool. But if you are changing your design, you will have to change your test. That's impossible to avoid. But what I'm saying that it is okay for that to happen, and it will make you understand more the changes that you are doing, and also to be sure that you are doing them correctly. If you don't have the test, maybe you will think that you will do it faster, but you won't be sure that you did it right. Okay? And that time that you think that you did it faster, maybe it will take you more time because you created an error that will, you will discover in production, and you'll know what happens after that. Okay? So, okay. Thank you.